You're listening to Don't Waste Water.
In order to change an industry, you have to change how things are done. And how things are done is a lot of money, tens of millions of dollars invested in big facilities trying to create the next big thing. That's not my answer.
Hello, bonjour, and welcome to the Don't Waste Water podcast.
KFC. We built the mother KFC here. I'm the colonel with the thing, and you become a franchisee of Active Membrane.
I'm your host, Antoine Walter, and in today's episode, I'm delighted to welcome Arian Edalat as my guest.
This industry has to change. It's a dinosaur waiting for an asteroid.
Arian is the CEO and co-founder of Active Membranes.
Again, I'm not Gandhi. I like to make money, and I have fiduciary responsibilities to make money for all my investors, and we will do that.
Active Membranes is innovating the future of fresh water by redefining the technology used in membrane desalination.
You're looking at it as a standard membrane company. You shouldn't.
And before we start, let me thank my sponsors, Simple Lab and Bluefoot Membranes.
My goal with this technology, eventually, is to democratize desalination, to make it more cost-effective at any scale so that the market can change.
There is a moment in today's conversation where Arian describes how he and two colleagues built their first electrically conductive membrane coating machine. They bought a drum from Home Depot, grabbed a handheld paint sprayer, the kind you'd use on your walls, and started coating membranes in what can only be described as the water tech equivalent of a GarageBand setup. Total cost, $200. I know this sounds like the typical and mythical startup story, but I believe it's more than that. It's a masterclass in what I've been calling seed strapping, a philosophy that's quietly changing how water tech companies should think about growth, capital, and maybe survival. Here's what the numbers tell us. In 2025, investors poured $600 million into water tech. If we exclude the Tidal Vision outlier that evens out the Lilac Solutions outlier from last year, that's slightly more checks than in 2024, but also each one getting 10% smaller. Somehow, the market is literally voting with its wallets for something different. Not the go big or go home mentality of traditional VC, but something more disciplined, maybe? In any case, something more like what Arian is building at Active Membranes. I've talked about VC maths on that microphone before, but let me recall some stats. 65% of investments fail to return even one time the invested capital, and only 4% produce those mythical 10x returns. And that's across all sectors, not only water tech. And it includes all the ones where you can raise millions on an idea and a PowerPoint deck. Now, as you know, water tech is not like that. If you don't have $500,000 in revenue or at least some sort of paying customers, you won't get lots of callbacks even from the most risky VCs. You need proof, not projections. So when Arian tells us today he's only raised $3.2 million in total, including grants and non-dilutive funding, and plans to raise just $5 million before reaching profitability, he's not being modest or lacking ambition, he's being revolutionary, and I believe it's important to flip that script here, because he's actually following a playbook that water VCs themselves are quietly endorsing, even as it challenges everything we think we know about scaling technology companies. Here's what Arian told me.
I am against raising money for the sake of raising money. While raising a $50 million round is a good discussion at a dinner party, what good does it do to have to see whether it's useful for me or not?
Hearing this from a CEO whose technology could fundamentally change how we approach desalination, reducing chemical use by up to 100%, increasing water recovery by 45%, cutting life cycle costs by up to 60% is, let's say, unexpected. Those are the kind of numbers that would have most founders racing to Sand Hill Road with visions of unicorn valuation dancing in their heads. But Arian has seen the other side. He spent the first half of his career as a desalination plant operator. He's stood in 50 degrees Celsius heat watching communities go without water because a membrane failed and the plant went down. That's invaluable, but doesn't turn him into a philanthropist either.
Again, I'm not Gandhi. I like to make money.
He knows that in water tech, the graveyards are full of well-funded companies that never understood the problem they were trying to solve. And this is where seed strapping becomes more than just capital efficiency, it becomes a survival strategy. When you bootstrap to your first $500 500K in revenue using grants, foundations, and yes, even your grandmother's retirement fund, as I half jokingly suggest in this week's newsletter. If you're not yet subscribed, it's free and the link is in the description. You're not just preserving equity, you're forcing yourself to build something the market actually wants. You're developing what researchers call creative constraints, that inverted U-curve where having less money actually makes you more innovative. And I promise, I'm not using that to tell you the story of Apollo 13 one more time on that microphone. Now, is that universal truth? Not fully, I acknowledge that, because gradient successfully exists. Yes, early investors might be virtually sitting on 235x returns, and the secondaries that happened probably provided the best returns ever in water tech and double-digit multiples. But gradient had MIT's network, perfect timing, exceptional founders, and patient investors focused on impact over quick exits. Can you replicate that? If we're realistic, probably not. But what you can replicate for sure is the discipline of treating capital like a scarce resource, even when it's not, of building production capacity like Active Membranes does with Spitfire, their affectionately named coating machine inspired by rock weaving frames, rather than investing millions in traditional membrane manufacturing infrastructure. The discipline of envisioning a franchise model where production comes to the market, not the other way around. KFC for membranes, if you will, and as Arian calls it.
I'm the colonel with the thing.
Peter Yoles from Echo River Capital, one of Arian's investors, told me something on that microphone a couple of months ago that should be told in water tech entrepreneurship schools, if those existed.
I'm looking for that long runway of technology development before the founders try to raise dilutive capital. They can raise grants and foundation funds and support and SBIR loans and all kinds of non-dilutive sources that are widely available today to help them get to the point where the company is well on its way to being successful before they try to dilute their own stakes with investor equity.
When has a VC ever told anyone to take less of their money? Well, in water tech, they are practically begging you to. The paradox is beautiful. Water VCs want you to bootstrap because it de-risks their investment. They'd rather invest in a company that doesn't need them than one that does. And the founders who say, we're not raising right now, are usually the ones investors end up chasing. So all that being said, Active Membranes is at a tipping point right now. And the company that repeatedly wasn't raising yet is now ready to raise. And if you don't know yet if that's enticing or not, this is not investment advice, well, you'll get your answer in this week's conversation, so I leave Arian the floor right after I remind you that if you like what you hear, please take this episode and share it with a friend, a colleague, your boss, or your team. Make sure to subscribe, and I'll meet you on the other side. Hi, Arian. Welcome to the show.
Thank you for the opportunity and good to be here.
I almost wanted to say welcome back because we already had a recorded conversation, but it wasn't on the podcast. It was on the Water Show. At the time, you were just winning the Tech Idol at the Global Water Summit in Berlin. We'll come back to that one because I'd like to understand how important that is in the path. I think I discussed that with Prakash Govindan from Gradients, because he's one of the alumni of the winners of that prize. But before that, let's really start with what you're doing specifically. Reverse osmosis membranes tend to fall and scale, and you go at it with a differentiated take. So first, is that the problem number one you're aiming at? And if that's the case, what's your differentiated solution to that?
To answer that a little bit better, I have to give you a little bit of my own background. Since late 2003, when I finished my PhD, I have had my entire career in desalination, membrane-based processes and desalination, 22 years now. And I started the first half of my career operating desalination plants. It was a new technology still at the time. Not many people understood the scaling and fouling. And so I've had a first row seat to this phenomena. And how does it impact? Nowadays, people say, well, we just clean it and it's all good and whatever. It's not. As an operator, I can tell you that it's a pest. It's a nuisance. It impacts operation. If you're outside, there's a 50 degrees centigrade weather and the desalination plant is feeding a community that is reliant on that water. Every hour that plant is out because of some corrective action regarding fouling and the scaling, that's an hour that community doesn't have water. It is the tail that wags the dog. Everything in a desalination plant is designed around one way or another mitigating scaling and fouling. From pretreatment, from the hydraulics that you design, from the recovery that you're trying to control, all of that, everything, every nuts and bolts, one way or another, is related to control and mitigate an inhibition of scaling and fouling. Now, how we approach it is, let's take a step back. Why does it happen? It happens because membranes, whether they are from one company or another or one technology or another, the phenomena of separation is a passive phenomena. It means that you pass the water through the membrane, you clean up what you clean up, and there's a concentrate that goes out, and so on. Now, the membrane itself is a dumb plastic. It doesn't have any control over what it sees or what it separates or how it fouls. So it definitely relies on all those nuts and bolts preceding it to be able to mitigate the scaling and fouling. Early in my career, there was always a thought in my head when I was in these plants and I was young and I was imaginative. If I could talk to these membranes every morning, hi, how are you? How you doing? What's going on? How's the gypsum treating you? And this kind of thing. And that is the core idea early in my career behind what years later became active membranes. Now, like every other venture, active membrane is a combination of a personal story and circumstance and serendipity. Fast forward a number of years. 2019, I started a company with a couple of my colleagues, Eric Hook and Rick Wolfen, and a couple of my partners, mainly because Rick was generous enough to seed a business and ask me to run that business. That company called Pacifica Water Solutions still operates. Pacifica Water Solutions was supposed to be a technology service provider to the likes of SWA, to the likes of NEOM and other folks that want to develop something. And the company made some money. And then back in 2022, we wanted to decide whether we should reinvest this money into expanding our boutique consultancy business or spend it in a venture. It was only serendipitous that at the time, the work that is behind active membrane came out for technology licensing out of UCLA. I know the inventor very well, David Jasby, and I know the work very well. I knew it from 10 years before, and I always thought that this has the potential to change this fouling and scaling game. So I took a license on it, but what active membrane does is change that phenomena of passive separation into an active separation, hence the name active membranes. Why? Because if you give the membrane the power, some means to control that fouling and scaling without having to rely on upstream processes, you have changed the phenomena of scaling and fouling, and yet you have changed the phenomena of desalination and water separation. I don't like passive processes. I like processes that take control in their hand. You're giving membrane the control, theoretically, to do what it's supposed to do. In our case, the way we are doing it is through electricity, by making membrane electrically conductive. And when it's electrically conductive, we can add an electricity to it. Some form of electricity, in our case, is a low potential AC, alternative current. And when you do that, the membrane now has the power to repel charges in the feed channel. And that changes the phenomena of nucleation of these contaminants on the surface of the membrane, as long as the contaminants are charged. And it also changed the phenomena of separation and nucleation and processes. Now, the beauty of it, the bigger picture, is when you send electrons back and forth to a medium, now you have established the language. Now you have to learn the language. How do you learn it? By operating it. Those folks, the archaeologists that dig up Egypt or Middle East or Babylon, they found these texts. The language was there. They just had to learn it and figure out what those guys did in the back time. I understand that I'm mythifying a little bit and fabling a little bit, but that's the imagination. That's the idea behind it. I like to make smart membranes that we can talk to, and they can talk back to us and tell us what's going on and how they can run at their best efficiency. That is the key difference between what active membrane does and all of my other colleagues at Zuiter Co. or Nala Membrane or other folks does. It is a difference between a passive and active separation phenomena.
Let me unpack all of that. First, on the story itself, I think that's interesting. You've built a company which was advising on tech and which is an expert in desalination. So you started by studying and living the problem. And then you thought, okay, I want to look at a solution, and it happens that the solution just next door to you almost comes out and say, oh, that fits to the problem I've identified, so I can bind that to it and become a tech play. If I try to rationalize your tech, it sounds like it's going to be utterly wrong, but just to give an image of it, like an electromagnet. You're putting some electricity and then it becomes a magnet that can attract or repel stuff. And if that stuff is charged, well, you can repel that stuff. And then depending on how you see the changes in the current, you can start to have, as you say, a language with the membrane. What is the key message you take out of what the membrane says? Is it you can clean faster, you can do that or this, or I am going to be dirty, I need to be backwashed? Or what is exactly the type of messages you can share with that membrane that now is talking?
So the membrane can definitely tell you when it's getting dirty. And it says, I'm getting dirty. The force that you're giving me, the voltage and the current and the frequency and this kind of thing that you're giving me is not enough. So either work with that, give me another set of conditions so I can mitigate this problem a lot easier. Or over time, my goal is to collect enough data so the membrane can make that decision on its own. That's the bigger picture for active membrane. Right now, that's not enough. So I'll give you an example. Let's assume one pretty notorious scalant, gypsum, calcium sulfate. What we have found out, for the sake of argument, conditions where in terms of voltage, in terms of frequency of application of that voltage, and in terms of electricity, there are certain areas that this is anti-scaling phenomenon on the membrane works, and there are certain areas that anti-scaling phenomenon that membrane worsens. So when I'm talking about language, we learn that because the membrane tells us. You immediately start seeing changes in performance of the membrane, and that's the message. You would not be able to see that. Often with the scaling and fouling, you find out after the fact. Here, it's almost immediate. And then if you have an advanced warning of something, then you can change that. Now, it's not just an advanced warning. It's a membrane that has the potential to correct, to meet that advanced warning, and so on and so forth. So the goal here is eventually learning from that membrane what it communicates back to you in terms of performance, and then enabling that membrane with tools that can take corrective action to correct itself. What is that tool? The three things that you have. The potential that you applied that electricity on, the waveform and the frequency that you applied that electricity, and eventually the current that you applied that electricity. If you take all three of those into consideration, for every scaling, for every fouling, for every water quality, there would be an optimal process. And what we'd like to do is to get there, to understand how can we mitigate gypsum with this water quality at what things. And that is the basis of a smart desalination system. And a smart desalination system that is leaner because you don't need as many pretreatment as you can. It's cheaper, more cost effective, and it's more sustainable and up and running. Now, imagine big question at the middle of it. Why doesn't desalination scale? Why this market is limited? The reason is because of all of that, because of the footprint, because of the cost, because of the complexity of these processes. And hence, while Dubai's of the world and Jeddah's of the world, where there is the political will and the money to make it work and make it cost effective exist, it is the smaller communities that are deprived of this technology. One technology that we rely on to solve the water scarcity, because 97% of our water resources are saline. Whether we like it or not, we have to desalinate them. It's not a matter of choice. It's a matter of existential necessity. And one technology that we rely on, it's not cost effective at the scales that are smaller than a community of 10,000, community of 5,000. Some were deep in Africa, some were deep in Middle East. My goal with this technology, eventually, is to democratize desalination, to make it more cost-effective at any scale so that the market can change. There will be more access, more cost-effective access for communities of lesser fortune than the communities that are enjoying it now. So we can solve this problem once and for all. And you cannot do that unless you change that separation phenomenon. That is what active membrane is trying to do, making things smart.
Let's hear from my sponsor, Simple Lab. Testing water and everything around it should be simple. With Simple Lab, you choose what to test, from drinking water and wastewater to soil, air, food, and surfaces, and they handle the rest. Kits arrive at your door with free round-trip shipping, samples go to certified labs, and results come back fast, concise, and actionable. Trusted by leading brands and growing teams, Simple Lab offers hundreds of ways to better understand your environment. Get started today at gosimplelab.com. It's the first link in the description. Thanks Simple Lab for supporting my work, and back to me. Again, lots to unpack, so thanks a lot for that. Let me try to chunk it into pieces. First, I'd like to just close the arc on the discussion with the membrane and what it enables. Because again, if I try to make a simple analogy, it sounds to me like a shower head. You have your shower head and it starts to scale, basically. If you see it starts to scale, you can put your hand over it and then it's going to keep working as smooth as it can. Whereas if you don't do that on a daily or weekly basis, at some point your shower head is dead and you need to change it. So what you're saying is that you can have those very early indicators that something's happening on the surface of the membrane and then play with the potential, the waveform, the current, so that you can brush it off like I would do with my shower head. Which begs the question to me, does that happen at the membrane level, at the module level, at the skid level? Where do you put that intelligence? I imagine it's not fiber by fiber.
The medium for that thing is the module. We make a spiral van modules. We don't want to reinvent the wheel. There are pressure vessels, there are modules, the spiral van works, everybody loves it. There are many plants out there that are using this spiral van module. So we've developed our product as a spiral van module. That spiral van module is easily adaptable and retrofittable in existing pressure vessels without altering the pressure vessel. So that's the medium of doing it. Now, what we have also done is that we have made a small box. We call it active box. That active box is essentially a function generator. You can hook it up to one pressure vessel. You can hook it up to the entire skid. You can hook it up to everything. And what it does is that it gives that signal to membrane. You're running at 4 volts at 1 hertz. And you're running it as a sinus wave. Start with that. And then you get the message and you start seeing the operation of the plant. And that operation of the plant will tell you whether or not that is good or you're mitigating a skinning or fouling. What we have done so far in our pilots, we've done head-to-head, active membrane versus a standard membrane. And when you monitor that, you will start seeing whether you're making any difference with that device or not. So our work so far, and I'm continuing to do so, is the module level, the spiral van module level, as well as that active box that sends and receives that signal back and forth between the pressure vessel that is housing those active membranes.
You're tempting me too strong with that one. I need to ask you, if you do head-to-head comparison between active membranes and traditional, what I took from your website is that you can go up to 45% higher in water recovery and you can have up to 50% cost reduction. Maybe one leads to the other. Can we qualify the claims? If you're on inland brackish water, what would you see? If you're on an island, what would you see? You're talking of these smaller communities. I guess that's where the biggest difference is going to happen. And if you're on a ultra highly saline produced water, what would you see? Just to give some ballpark figures. If you have better examples, pick your examples.
No, absolutely. So we're looking at the standard desalination applications, brackish water, where we do very well, and seawater, where we do well too. Now, in a brackish water application, 45% recovery is a little too high. I think we're talking about footprint rather than recovery, but we can operate at a high recovery with much less chemical. So give you an example, a pilot that we've run in Yuma, Arizona, our first validation long-term pilot, we ran it in an environment where there was an existing surface brackish water running at 74%, 75% recovery. Without chemistry, we managed to run it at 84% recovery and get better application. And then we took the brine from that application and we run it at another 65% recovery, overall getting around 92% recovery of an existing plant. What does that do to you? Life cycle costs. What is impact? Cost of chemistry, cost of waste disposal, because now you have less brine, cost of membrane replacement. You have less cleaning event. For the passive one that we operated on those operations, we had 9 cleaning events over the course of 9 months. Here we only had 3. So when you put all of that together, you're getting cost saving, life cycle cost savings of an existing plant, anywhere from 34%, 32%, all the way up to 60%, depending on what recovery you're running it at. In a seawater application, there are 2 distinct advantages that we can provide. The first advantage is eliminating chemistry and mitigating biofouling using those active membranes. Because the salinity is higher, it's not as much as a brackish water where everything is all about the scaling, but it is at least 20 to 30% cost savings. But more importantly, what we have identified and filed a patent on is that we can enhance boron rejection. Now, boron is a problem in desalination. I'll give you an example. In a country like Israel, where seawater desalination is predominant form of fresh water, in that country, they use desalination for agricultural purposes. Now, boron to crops, to soil, is poison. So they have very stringent reduction of boron concentration in the permeate that they use, right? Now, why is boron a problem with desalination? Because from a chemical standpoint, at neutral pHs that usually seawater is, boron rejection through a standard membrane is limited because the boron resides as boric acid, poorly rejected. You have to raise the pH of the water to 10.2 or thereabouts in order to change the form of boron from boric acid to borate so you can enhance rejection of the membrane. Now, that requires a lot of caustic sodium hydroxide. Now, you have that, and then you end up with a high pH water. As you permeate, you have to bring it down, so that requires acid. Now, regardless of the cost, handling acid or caustic soda, operators hate that. Let's imagine. So what we can do is we can eliminate that sodium hydroxide dosing because electricity can do what that sodium hydroxide does at a much lower cost, at a much easier cost. So the operator doesn't have to deal with that chemistry. And it's an important application for us because it eliminates a significant OPEX cost standpoint for a plant that is operating in the desert or anywhere for that matter. In California, we have a boron issue as well. These are the value propositions. Now, one more value proposition, an important one, is that we can reduce the footprint of new desalination plants. How can we do that?
I was going to ask.
We can reduce...
Because that's brownfield, now it's greenfield. Yeah.
Now, let's move to greenfield. We can reduce the footprint because you don't need as complicated as this. For example, here, back in 2018, very close to where I am today, at an oil and gas produced water desalination application, I used a significant amount of chemical clarification, 2 stages, a lot of chemistry, a lot of waste, a lot of solid waste that had to be hauled off from the site. We just ran an application here, same place, same water. We eliminated chemical clarification steps, reduced the footprint by at least 50%, cost by at least 50%. Imagine if that happens, there are less trucks on the road hauling chemicals, there are less everything. So not only you're reducing the physical footprint, you're also reducing the environmental footprint of desalination processes. Another key important issue where you're trying to make sure that this technology scales beyond what it is right now. Those are the value propositions of active membrane. Again, active membrane, it can make any of those membrane into an active membrane. It is the phenomenon. Membrane is only the medium.
Just to be clear here, because I'm the muggle in the room, I did physics a long time ago. You really can apply your current to any type of membranes. It's not like there is no material which wouldn't work.
We have to apply our coating on it. That's our secret sauce. That coating is something that we've developed over the past 2.5 years. We have been through 2 generations of it. Now we are applying our current generation, which makes any polyamide membrane a lot more conducting. Just to give you an example, physics is the funniest stuff, and I always hated it, but I always end up to it because that was my PhD all the way onwards. There is a term in physics called electrical resistivity, which a surface has a resistivity, and it's got a funny unit, ohm per square, just a square, which means that the square of that thing, without getting too much into it, has a certain resistivity. Now, a polyamide surface has a resistivity of 10 to the power of 7 ohm per square. Very resistive, almost non-conducting. When we're done and dusted with a membrane, polyamide membrane, that resistivity reduces to about 100 to 200 ohm per square. Infinitely more conducting to electrical current. And the beauty of it is that we can make any polyamide membrane conducting.
5 powers difference between what it starts with and what it ends with.
That is the change of phenomena here. That's the secret sauce, essentially.
So you were so interesting that I broke my usual approach, which is to go through the history. But I think that's the point where I need to bring it back to just understand how you come to have that coating, because I understand the appeal of having this electromagnet that can repel the scalants. I understand the appeal of having the language, and I understand how you need to have the coating to get to have a lower resistivity, which in turn enables you to have these active membranes. But it's a lot of moving parts. Where do you start and how do you assemble those? It's like you start by thinking, oh, if only I could apply a current, and then you develop the coating, or you have the coating and then you say, oh, with that coating, I might be able to apply a current or do the 2 light bulbs light at the exact same time.
Back in 2020, when I decided to license this technology, obviously there was a method that David Jasby was using in his lab. So we had to transfer that method from his lab into something that we could take into the field. So crazy or not, there was a competition held by USBR called More Water, Less Concentrate. And I went to my team, but when I say my team, take it with a pinch of salt. It was me, and it was just one membrane scientist at the time, and another gentleman who helped with that technology. The 3 of us sat down and said, look, we're going to make a membrane, an electrically conducting membrane. We're going to take it to this competition. We're going to hope for the best. So we had to transfer what David was doing in his lab into something that we can make bigger sheets so we can roll a small module. If I show you the picture, you will laugh at it. We created this Home Depot drum that we put the membrane on, and we started coating it with a handheld. She used to paint your wall.
Yeah.
It didn't cost more than $200, but it did the job, right? So now we said, how can we do this so we can create larger, longer sheets? Because we need longer sheets for longer, bigger modules. Cut a very long and painful story short. We have created this machine, this coating machine that we call, affectionately, we call the Spitfire. Now, Spitfire, uses combination of spraying and heat to apply the coating to the surface at a very scalable, at a very low-cost method. The development team's focus over the past year, and they have done a fantastic job, has been trying to apply this coating as homogeneously as we can, because that's important, and as quick as we can. And we have managed to do that using this machine. Now, how does the Spitfire came into development? We have identified at least 20 spraying technologies, spraying devices, to see which one works, which one doesn't. And again, to cut a very painful story short, we settled on one of them that was robust enough to give us the level of consistency that we'd require. The idea behind the Spitfire itself is inspired from rock weaving frames. So that's the spirit behind it. And we are into the second generation of these Spitfire. The first ones used a lot of rudimentary stuff, but it got us through a lot of pilots. And the second generation right now is more automated, far more efficient than what it used to be. And why is that important? Now, as a membrane company, you have 2 choices. You either have to go and invest in significant amount of money in getting big, chunky membrane making stuff. I didn't have that luxury. I didn't have that much money. So we had to be creative about this. We had to make it scalable, and we had to make it cheap using stuff that are available out there. So we can scale up as our capacity builds up with much less capacity requirements. That has been the story of getting it mid-2020 out of David's lab, and right now in a way that we can coat commercially and successfully wide enough, large enough sheets that can be used in 4-inch elements, in 8-inch elements of any kind.
Have you ever heard of a membrane that refuses to break? It sounds uncommon, but it's true. Meet Bluefoot Membranes, a Belgian company that has developed the first and only unbreakable membrane specifically designed for MBR. If you're new here, membrane bioreactor applications. This technology is setting a new standard in wastewater treatment. Water engineers and industry experts have tested this membrane, and no matter how much they pull and twist, the membrane holds strong. Now, it's not just about membranes, it's also about an award-winning and passionate team that doesn't take impossible as an answer. The people at Bluefoot Membranes are driven by a mission to make wastewater reuse the new standard, united by a shared purpose to leave a blue footprint on the world. So yes, they manufacture cool membranes, but they also push the boundaries of what's possible in MBR technology. To learn more about them, check the link to their website in the description. A big thanks to Bluefoot Membranes for sponsoring this episode, and back to me. Something I discussed on that microphone with Evolve twice, once with Chris Wires and the second time with Henry Walker a couple of weeks ago, is what do you want to become as a membrane company? And the reason I was asking that to Evolve will sound familiar to you. It's because they developed a specific way to 3D print their membranes, and they had to basically develop the machinery in order to deliver the membranes. And when you're in that spot, you could basically become a printing company, a coating company, or the hardware company which enables others to produce the membranes. When I hear you and your Spitfire story, it sounds like, sure, there is a lot of technology and a lot of understanding of the membrane around the coating itself and what you can do with the coating and how that it can apply in the field. But the very strongly differentiated take is that you have that machine and now you can keep it to yourself, or you can sell it or license it. What is your vision with that?
So all of these are means to an end. At the end of it, the goal is to redefine the desalination market. Redefine it in a way that it becomes more cost-effective and more accessible to people. Now, with the technology that we've developed, what I like to see is, and I tell this to every partner that comes to us, is that I'd like to eventually take production to your market. I do not like to have a massive production facility here in California. If you think in Western Mediterranean, and I've just came back from Malta, one of our colleagues over there, if you think you have enough membranes here, Spitfire comes to you, KFC. We built the mother KFC here. I'm the colonel with the thing, and you become a franchisee of active membrane. You take the production to your side. You have your own KFC. You have your own membrane coating and rolling facility, and then take it over there. Why? Because again, the question at the heart of it is why this is such a safely guarded industry with a few players. Two reasons, mainly because you require significant amount of capex to build this facility. So you have to break that mold. It doesn't have to be that expensive. The second thing is that it's focused and centralized in mega locations. With active membrane, I think our strategy would be to take production to the market. That market could be anywhere. Here in the US, we have our own facility. We try it out. We build something, but that model can be copy-pasted in markets of interest where our partners think they can make a living out of it.
So is that the short-term approach? Is that the midterm approach? How do you see that?
Because it's short and midterm. I have to penetrate market, right? And our strategy has been going after folks that we can work with in respective markets, start some initial traction with them, and then eventually it turns out into it gives them the competitive advantage over another OEM or another distributor or whatever, because now they have something unique that they can produce in-house. That gives them not only the competitive advantage, but also the inspirations to do a lot more than selling a product. So I would say short-term and mid-term.
But there's an element of market education to do here, because if one of your perks is to be able to reduce the chemicals and to reduce the pre-treatment and to reduce the peripherals, all fine, assuming someone is taking those wins. Because you could also just design with your membrane, and then the engineering bureau does exactly like they've always done. Because again, I keep saying that week after week, and I'm not charging them for that. It's the way that sector is built, but the business model of engineering consultants is copy-paste. That's how they do their margin. So now you're asking them to change their design, because if they don't, they're simply a more expensive single piece of membrane. The savings comes from the reduction of the peripherals. So you need to convince them. How do you do that?
Active membrane doesn't change how our membranes are designed or built. The pressure vessels are still there. The high pressure pump is still there. You still need the minimum level of pre-treatment. Essentially, when you look at an RO system that is run by active membrane, you will still the same usual suspect. You see the same hardware. What we try to do is to minimize the pre-treatment. We try to minimize the cost of operating that plant, the cost of building that plant. Now, why is that important? I'll give you an example. If you are an OEM, would you like to sell one plant a year at $1 million, right? Or would you like to sell 10 plants at, let's say, $500,000. What we are enabling to do is to change their market share and their market size. Why? Because now the application is applicable to markets that have not had a reach to before. It's an economy of a scale.
I get your point, and I'm fully with you. Don't get me wrong here. My concern is more on the OEM brings a skid, brings a system, but will not hold a process guarantee most of the time. So the process guarantee is held by either an EPC or more probably an engineering consultant. That engineering consultant, if his entire life he's designed desalination systems with a full-blown pre-treatment and also with a duty standby, because you never have too much pre-treatment. And then he also has chemical treatment and backwash, and he also has a cleaning in place, and he has, even if it doesn't make sense, the two of them at the same place, and he again has duty standby, because you're never too safe. And now you come and you say, you know what? You could be going at different scales, and you could be addressing different markets, and the cake becomes so much larger, but he needs to engineer again. And again, his business is to copy paste what he's done, because he's been losing money on the first 3 plants to engineer it, and now he's recovering his margin through the copy paste. So how do you convince that guy to take the plunge with you and to rethink the way a treatment train is designed?
He can still copy paste. He's just not copy pasting the chemical clarifier. He's just still copy-pasting the RO skid. We're not changing the design of that skid. The whole point of active membrane is to activate and make existing desalination designs smart. Not to risk that this is the same form factor as a spiral valve. The entire skid remains the same. You just don't put a chemical clarifier ahead of it, or you're one dosing pump or two dosing pump less when you're designing this. And that's where the new plants start. Now, as a result, you make the plant more footprint friendly and more cost effective. So your design as a consultant will have a higher chance of succeeding and turning into something that is operating than a complicated plant that looks like a spaghetti bowl.
Last one on that topic.
Again, an operator's mindset. I've been an operator half my career. That's the operator's mindset.
Get you. Yeah, my last one here is pretty simple. We brushed over a range of benefits that your approach has. I'm a believer in a single aha moment. So you've done pilots, you've done testings. When people see your technology for the first time, especially one-to-one running next to traditional ones, so they have the direct comparison, what is the single metric they look at and they say, wow, you can do that? Game changing.
No chemical use. So you're not using antiscalant? No, we're not. Oh, wow. That's because you're changing paradigm here. You're changing perception and complexity of desalination plants. So footprint and lack of use of chem pretreatment is the one that stands out.
Which circles smoothly back to what you said as an operator, that you hate the chemicals. And so, of course, if you don't have the chemicals, then you're happy about that. Makes sense.
I don't want to make beef with chemical suppliers. They're all good. They're going to be used for a while. But the point is, the less of them we can use in a desalination plant is going to be good for everybody. I'm old enough, so when I was a student, we didn't have these guys, the smartphones. My darling mom used to call me once a week because it was expensive, it was difficult. Now, right now, courtesy of this little guy, my mother calls me 20 times a week. Not necessarily a good thing, but it tells you how you can change the paradigm of an industry and it still be profitable and everybody can benefit from it.
So 2 keywords, one you just said and one you said a while ago. So I'm going to try with starting by the one you just said, being profitable. Are you profitable today?
No.
Which leads me to point number 2, which you said a while ago. You don't have that much money. You have limited means. In terms of raising, you raised a round with an investor that's raving about you. I had Peter Yolls on that microphone, and you were an example. He was coming back regularly saying, oh, those guys are really doing something. But Peter is an early stage investor. So that means if he's your investor for now, that means you've raised an early round. So what is the vision here? Is it to go down and sorry to mention them again, the Zwitterco path and then raise several tens of millions to get to the next scale? Or is it to look at that market and saying, you know what, it's an oligopolistic market. There are only so much RO membrane producers, roughly 5, arguably 3 big ones, and then some others. Those guys are not the best in terms of creative R&D because that would be disrupting their base model, but they are keen to look at companies with interesting tech and to, I'm not even talking of acquiring at that stage, but at least partner and develop stuff together. Which of those 2 paths would be the best one for you?
So while raising outrageous now, and again, all of these guys that you mentioned are my friends, but I am against raising money for the sake of raising money. While raising a $50 million round is a good discussion at a dinner party, what good does it do to have to see whether it's useful for me or not? Right now, we have a very interesting paradigm. We have more demand that we can address. So I have to build some infrastructure. So far, we've raised about $3.2 million in various assets, grants, non-dilutive, award money, a seed round that we closed last July. Peter is amazing. So lucky to have him as an investor. But more than that, the check size doesn't matter. Having him as somebody who advises and we talk on frequently. There's Natural Ventures who led that round, Martin and Mark Jenkins, amazing folks. My own company, Pacifica Water Solution, participated in that round, so I have my own money in the business, and a few other folks. We are now raising another round, that $5 million round, and this round is probably, I'm aiming it to be the last round we raise, because after that, we're hoping to get profitability level, and then when we have an at least break-even point, and then there's a business plan that supports this based on the pipeline that we already have and the places that we are piloting at over the next few years. This business is going to be doing, and it has so far, a lot more with much less capital. So it's a high return on investment for the investors that participated in it. And because of that, I think it's pretty special because of the nature of the things that is provided.
But let me be the devil's advocate here. When I discussed that with Peter, overall, his investment philosophy is that he believes 100x are doable in water. And again, 100x, let's not even get at that. Let's go at 10x, which would be unseen of in water VC so far. If you're going down that path, 10 to 100x in 6 to 8 years, you have to hypergrow. And hypergrow in a field like membranes is very doable on the paper because you have that element of a bit of the Nespresso machine. But the other side of that is that there is a high cash barrier upfront because you need to invest in Spitfire machines, because you need to invest in production, because you need to invest in footprint all around the world. Even if you do a franchise level, there is still a cash flow topic because that means you need to build the machines upfront and then deliver, and then only the cash comes back. So when I hear that you want to raise 5 million, then that's the last round, I'm wondering if that fits with the vision of a 10 to 100x. So prove me wrong.
You're looking at it as a standard membrane company. You shouldn't, because this company, the way we've developed things, the technology that we've developed, the impact it will have is beyond membrane. Membrane is a means to an end. And the way we coat these membranes are low capital, deliberately so low capital, because the mistakes are much smaller. The path through growth is much more nimble and much more quicker than having to take 24 months to build a massive production facility only to find out that it's only 50% effective at times. So I deliberately didn't go through that route because I've seen it before and I don't want to carry out the biggest still elephant around. The purpose of this thing, the impact it will have, is changing the phenomena, not necessarily the means to an end, changing the phenomena of separation at the back end of it, and doing it with much less capital than the standard water startups, membrane startups usually do. That's the point. That's the whole point of this company. If my philosophy proves, and in 4 to 5 times we have created something that is unheard of, then I've proven right. Only time will tell. But if not, then, I'll come back to you and look for a job. But I believe that I have to have, my kids will be in college by then. But I truly believe that in order to change an industry, you have to change how things are done. And how things are done is a lot of money, tens of millions of dollars invested in big facilities trying to create the next big thing. That's not my answer. My answer is doing it, getting there, doing it smartly by changing the phenomena of separation. And how do you change that phenomenon of separation? Active Membranes has found a way to do that with much less capital than all our counterparts do. That's a high ROI industry over there. And when you manage to do that, when you manage to get something like this into a market that everybody thought it was all saturated and all done with, right? Phones worked. Nobody thought, but when this thing came, changed this thing completely, changed the landscape completely. That's what I like to do. That's my mission in this market with Active Membrane, to change that paradigm, to change that landscape to something that nobody ever thought imaginable.
I have 2 questions for you left in this deep dive, one anecdotal and one more serious one, but which leads to the same direction. You're mentioning you want to change this industry. How does the industry react to that? That's my anecdotal one, because I've seen you winning that award, this Tech Idol award. And sometimes I'm thinking that's the industry endorsing it. And sometimes I'm thinking that's the industry giving you a toy and saying, okay, go play with it.
While those awards are important, they're important as an early stage recognition from an industry. And then they serve a purpose. As I said back in 23, when we were sitting in that beautiful room in Berlin, success is good, but don't let it define you and distract you from your message. This industry has to change. It's a dinosaur waiting for an asteroid. And if it needs to meet a global existential crisis such as water scarcity, it definitely has to change. If it doesn't, then it's left behind. And humanity is left behind. We cannot afford that. We cannot do that. Somebody's got to do something. And that has to be the way. It either changes or you change it or it's left behind. I don't wait for the industry to dictate to me what it is. We have identified the needs in the industry and we're going to change it one way or another. And unless that asteroid hits me first and we die and the whole thing goes down the drain, or I cannot raise money enough quick enough so that the whole thing dies, that's going to happen. But that's what it means to be an entrepreneur with a chip on your shoulder.
So that was the anecdotal one, which you gave a very deep answer to it. So somewhat you're in line with my deeper one, which is If you look on the horizon, and I have to acknowledge before sending you to the horizon that you have one of the fastest paths across the 250 companies I've interviewed on that microphone so far. Because if people got the dates right and realized what we're discussing here, you went very fast from licensing that technology to getting it to market, prove it with pilots. So that's why 2030 is getting closer, but to you, it's far away because that doubles the life of your company. So what is active membranes by 2030 and what needs to happen in the next 12 months if we reverse engineer that to make it happen?
So I have to increase the bandwidth, our production bandwidth over the next, raise the money and increase our production bandwidth so we can keep up with the demand that we have. And that needs to happen by 2030. Active membrane is either has caused one of the best deals in this industry and somebody comes and buys us and makes the better. Please remember that this is about the industry. Again, I'm not Gandhi. I like to make money and I have fiduciary responsibilities to make money for all my investors and we will do that. So a good exit would be nice at some point, but it's all about the industry. It's not about me. It's not about, at the end of the day, it's not about money. We all can agree that there are much easier ways of making money than trying to do a water startup. It's all about the industry and it's all about the impact. I like to see it have the impact in 2030 that I anticipated for it to have, changing the industry, and somebody would recognize that and has the means to enable that at a much larger scale. And we like to team up or form of an exit or an M&A or whatever at that time. So we can keep the existing investors happy as well as at the same time maintain the impact that we'd like to have on this industry.
And so what needs to happen in the next 12 months? Like really short term?
I have to create the foundation in the next 12 months for it to happen. And that foundation starts with my home KFC. I have to build a home KFC here, and then so I can make it, replicate it into franchisable model and take it to the markets. And at the same time, I have to build additional alliances. We have some great ones already. In Israel, we have a great set of folks that are working really hard, wars and things permitting. We have great partners in Mediterranean. We are making partnerships in the Middle East. So we have to cultivate those partnerships and put everything in place, all the simple building blocks in place in order to be able to implement the strategy that we have in mind.
Arian, it's been a pleasure to go through that full path. It was a long due discussion, so I'm really happy we had it.
Same here.
I am rounding off those interviews with a set of rapid fire questions.
It's time for the rapid fire questions.
What is the toughest challenge in your opinion for a water tech startup?
Funding.
What would be your best single piece of advice for the founders and managers of the about 1,000 early stage water startups?
Persevere.
What's the drop of knowledge you wish more investors knew about the water sector?
It's the future of humanity. Don't shy away from it.
What was your most unexpected partnership and what did it bring you?
It's a good question. My most unexpected partnership has been nothing technical. It's a little corny, but my family. Without whose support, without their understanding, the impact they have on your daily life, I would not be able to do this.
I would say corny. That's exactly, yeah, we're humans and you can't do anything if
without the support
you don't have
of
that. That's
exactly.
Yeah. Super short. Profitability or growth?
Growth.
What's the next profile you'll hire?
An operations manager.
And when you hire that operation managers, are looking for sector experience or startup experience?
Neither. I look for character.
That's a good one. Opening new markets or doubling down on the current ones?
Short-term doubling down on current ones.
What is that tool nobody speaks about, but you could not live without?
My phone, because I travel a lot and
I was expecting it.
This thing is managing things.
What is the single piece of insights your ideal customer profile needs to hear right now?
If you want a more cost-effective, more efficient operation, we are here. We are willing to provide performance guarantees, and we're looking for early adapters, and we support our early adapters a lot more than others.
What are you desperately needing and want to raise an open call for right now?
Our current investment round, essentially.
So what type of investors are you looking for?
Impact investors, lead investors, folks who believe that this is something as strongly as we believe in, so we can share this journey together and make some money in the process and change the world.
Corporate strategics, would you be open for that?
It doesn't matter. For me, again, going back to someone like Peter, it doesn't matter how much he invests or what his presence is, the impact it brings to the company, that's more important at this stage.
Last one, what can and should I do for you?
This is fantastic. I appreciate the platform and I appreciate the opportunity. If you can do something for me, raise awareness of our current round. That's all there is to it. And then make sure that people know that we want to do this. And because at the end of the day, with all said and done, with all the visions and everything, we have to make sure to be able to support that vision by funding the company going forward.
If people want to follow up with you after that, where should I redirect them the best?
Email is the best way of communicating with me. My first name, Arian, at ActiveMembrane.
Like always, if you want to follow up with Arian, the link is in the description, so have a look there. And Arian, I repeat myself here, thanks a lot for everything you shared today. And you know what? I even did it in time for your staff meeting, so I'm proud of myself here.
Thank you very much for the platform. It was a long overdue discussion. I always enjoy talking to you. And hopefully I wasn't too dreamy, but you can never be too dreamy if you want to change an industry.
That's the perfect conclusion.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.